We now move to recovery system. Introduction to crash recovery, stealing frames and forcing pages, recovery related during normal execution, overview of ARIES, failure classification, storage structure, recovery and atomicity, log-based recovery, recovery from concurrent transaction, buffer management, failure with loss of non-volatile storages. So this is a continuation of transaction actually, where we want to make sure that if there is some failure or crash, we might still be saving the things. So under normal execution, transaction take care of reliability providing locks where requested writes data is over to avoid lock of data system crashes. Stealing frames and forcing pages, steal approach the change made by object 0 by a transaction and return onto disk before the transaction is committed is because the transaction onto page loaded and with object OS optimal. So that is the steal approach. If the name suggests you would steal and save it to hard disk. Forced approach, all the objects in the buffer pool are forced to disk after the transaction is committed. The simplistic implementation is used to no steal approach. So whatever is in the buffer, just place it there. So that is the cache recovery. The simple recovery is to no steal force approach. With no steal, data will not be written. Transaction has the no need to. Though these approaches are simpler, they have certain. No steal approach requires a large pool buffer. And first approach involves expensive input-output cost because as you know that writing on hard disk is very bad. And steal and no force is implemented by recovery management. Using this technique, the page is not written on the disk when modified transaction and does not force the page return when transaction commits. Recovery related steps during normal execution. The recovery manager stores the modification made into storage which does not react to system failure. Such storage is called stable storage. The modification made to data is called log. Recovery manager holds log on the stable. And if the transaction is aborted, the log enables recovery manager to undo the operation and do the operation is committed. No force approach or write to data into this. So this is the normal execution. You have ARIES, analysis phase, redo phase, and undo phase, and rollback. So analysis phase analyze buffer to identify active transaction, dirty pages. If the modified page is loaded into disk before transaction, then must undo the modification in case of a crash. Redo phase, it must restore data when it was before the crash until it is done modified combination it is not in the cache. And rollback. So then we have the failure classification. There are various types of failure that may occur in the system. Each one need to be dealt with a different manner. The simplistic type of failure is the one that does not result in loss of information of the system. The logical error, system error. Logical error can no longer continue normal execution because system error is something like deadlock as something which hardware. System crash, there is a hardware malfunctioning, bug in the operating system and so on. The assumption that hardware works in software brings us to a halt but do not corrupt non-volatile storage is known as fail-stop assumption. Well designated system has numerous internal checks and the hardware software and bring data into halt. The disk block loses its current result or failure during the disk transfer, copies the data on the request for actual backup. To determine how the system should recover failure, we need to identify the failure model of those devices. Action taken during normal transfer to ensure enough information must allow the failure. Action taken after failure to recovery. So these are the two works. Storage structure. Various data must be stored and accessed in a number of different storage media. To understand how to ensure durability, we must better understand storage media access matters. Storage types. They can be distinguished by relative speed, capacity, resistance to failure. Stable storage implementation. To implement stable storage, we need to replicate data information in several non-volatile, usually disk. RAID system guarantee, a good idea. The books of self-completion, partial failure and total failure. Write the information on physical law, write complete service, the output is completed. Data access. Database is designed permanently on non-volatile, usually disk and is partitioned into fixed line storage called blocks. The assumption elastic for data processing such as RWing. The transaction and input information disk may inherit and output information into the disk. Block movement between disk and initiated through process. Input be transfer physical block to the memory, output transfer buffer block to the memory. This transaction is a private work in which copy is all accessed and updated by event. System creates a work area when transaction initiated. System removes when the transaction is over. Read X, write X. Read X is the value of the item taken from local variable. Execute the operation if block or access X. If assign X, the value from the buffer block. Write X, assign value of X to the block, executes the memory. Recovery and atomicity. So consider again a simplified banking system to transfer. So it's like the same way your banking system. If money comes somewhere, it should go somewhere. It should not just land in between. So if transaction has occurred, it should either come. The process will result in the value of A becoming rather than 950. Thus the recovery is inconsistent state. Do not execute the current state 950 A and B. The system enters an inconsistent state. So this procedure. Thus we can invoke possible procedures. The result value become 900 rather than 950. 950 and 2000 for A and B respective system occurs in log based recovery. Recovery algorithm are techniques to ensure database concern atomicity, durability. Action taken during normal process to ensure the information recovered from failure. Actions taken after failure to recover database contains consistent durability. While modifying the database without ensuring the transactional commit may leave the database in inconsistent state. Deferred database modification. The deferred database modification records all modification logout but defers all writes after partial commits. The transaction starts by using T-start record A, the write A operation in a log record, where V is the value for X. Write is not performed on X, is usually at time. The T partially commits is into log. During recovery after a transaction it will be redone if both. Redo. Immediate database modification. The immediate database schemes allow database updates on stored database even if on commit transaction. These updates are made right issue since undoing may be needed. Then we have checkpoints. We'll ignore this, but the checkpoint for a failure is like checkpoint system failure. Recovery with concurrent transaction. We can modify the log-based recovery to allow multiple transactions to execute currently. All transactions in a single disk buffer, single log. The buffer block can have data items updated by one transaction maximum concurrency using strict two-phase logging. And logging is done as described earlier. The checkpoint as actions is performed on recovery have to be changed since several transactions may be active and checkpoint. So initially undo list, redo list is empty, scan the log backward and then stop it. If the record log during backward scan to record log, T redo. Then we have buffer management, database monitoring, failure with non-volatile, and remote backup system. So network, backup site, primary site, transfer of control, and summary. So in the non-volatile, you have volatile storage, non-volatile storage, transaction failure. So when transaction reaches state format, commit all updates must remove from database on process atomicity, known as transaction rollback system failure. Then recovery must ensure that the updates are reflected. Media failure in this. And if you observe the blue screen of death, it always says that I am writing something to the memory. So probably I am writing some states where I am to the memory so that wherever things were you can change. So in the blue screen of death you still write that log to the memory so that when the system gets restarted you can actually have access to that. So we would like that to happen most of the time. Okay, I think that would do it. Thank you.